right, now, beginning on page 86, we have some operations with radicals, like combining like radicals. All right, let me go back and do a couple of real easy radical problems where we combine like radicals. For example, if you had 3 square root of 2 plus 5 square root of 2, they're exactly like radicals, aren't they? So 3 of these and 5 of those would be 8 of those, right? 8 radical 2. But what if it was 3 square root of 2 plus 5 cube root of 2? Now square roots and cube roots are different. So they're like unlike terms. Don't combine them together. Another thought is, what if you had 3 square root of 2 plus 5 square root of 3? Those are not like radicals, so you can't combine those together. Now what if I had something like 16 minus 8 radical 3? 16 is just a whole number. It's no radical. Now if I said 16 radical 3 minus 8 radical 3, what would that be? 16 radical 3 minus 8 radical 3 would be 8 radical 3, right? That is if it's got a radical 3 in both places. But what if it says 16 minus 8 radical 3? Then you can't combine those together because this is a number term, this is a square root of 3 term, and you can't combine unlike terms. So we'll have to leave those separate. All of these are separate unlike terms. But now let me give you one more thought. What if we had something like this? Building on this same idea. What if I had 3 square root of 2 plus 5 square root of 8? You might look at that and say, well, square root of 2, square root of 8, they're not like terms, are they? But what can you do with the square root of 8? You can simplify the square root of 8, can't you? In other words, that would be like 4 times 2. The square root of 4 is what? 2. So this way I could write this as 3 square root of 2 plus 5 times the square root of 4 is 2 square root of 2. Now what do you have?
13 square root.
Right? We'll have 10 here, 10 plus 3, which would be 13 square root of 2. You see that? Maybe I need to write it down. I'd have 3 square root of 2 plus 10 square root of 2, which would be 13 times the square root of 2. Okay? So that's how you combine like terms. Now sometimes they get uglier and nastier. Let me take a couple that might get a little more complicated than this. Let me start out with number 12. And then I'd like to move down to one that's got variables in it. 5 times the cube root of 16 plus 2 times the cube root of 54. Now, what are the magic numbers? Cube root. Cube root makes you think 8, 27, 64, 125, right? So, the perfect cube that divides into 16 would be 8. Let's make that 8 times 2, and let's make the 54 actually 27 times 2. You see that? So I can write 5 times the cube root of 8, cube root of 8 times the cube root of 2, and then plus 2 times the cube root, wrong color, cube root of 27 times the cube root of 2, okay? And then that would be 5 times, how much is that? 2, and then times the cube root of 2, plus 2 times, now what's this going to be? 3. And then times the cube root of 2. Now what? 10 times the cube root of 2 plus 6 times the cube root of 2, which would be 16 times the cube root of 2. Okay? Any question on that? All right? Good. Number 20. I believe it was number 20. Number 20, it says 3x squared y times the square root of 20x y to the fourth minus 2x square root of 45x to the third y to the sixth. All right? For my first step, let's sort this out. Let's make it a square root times the square root and a square root times the square root. And let's get it all sorted out. The numbers are going to be, the coefficients in front of the radical would be 3x squared y negative 2x. Now I'm going to take this 20 and find the perfect square. What perfect square would there be? 4, and the leftover number would be 5. Y to the fourth is a perfect square, so I'm going to bring out the y to the fourth, and leftover is going to be the x. So I'll have the perfect squares are going to be 4y to the fourth, and the 5x is left over. Okay? Now in the second radical, what's the perfect square? 9 times 5. Okay? And x cubed. Now x cubed is not a perfect square. So I'll have to break that down back off to x squared, and we'll have an x left over. And y to the sixth is a perfect square, so we just put it down like it is, y to the sixth. Okay? All right, now, come back to the beginning of the problem. 3x squared y stays the same. The square root of 4y to the fourth would be 2y squared, and then times the square root of 5x. And then minus 2x, and then we've got the square root of this is a perfect square. That's going to be 3x y cubed, okay? And then I've got the square root of 5x at the end. Can you simplify the coefficient? That would be 6x squared y cubed times the radical 5x. And then this part can be simplified, all right? This would be simplified to be negative 6x squared y cubed times the radical 5x. It's exactly the same, isn't it? So something minus itself would be 0. Equals 0. Okay? And that's it. Okay? Now when you get to the next page, by the way, the bottom of this page, this page gets tough. And then we begin over with a new concept on the next page. The next page begins products. And of course it begins very simply. For example, I just want to show you how simple this next page is. If you got panic-stricken at the bottom of page 87, take heart.